You ever wonder how your favorite streaming service just knows what movie to recommend next? Or, how your online shopping cart can remember what you put in it like a day ago? Well, the secret ingredient, the thing working behind the scenes of pretty much everything you do online, is this powerful language called SQL. So let's pull back the curtain and see what it's all about. Okay, so let's rewind for a second. For a really long time, this was the peak of information tech, the good old card catalog. And for its time, it was brilliant. You could find any book you wanted, by title, author, subject, you name it. Each little card was a pointer to a physical spot on a shelf. Super structured, super organized, but, and this is a big but, it was also incredibly slow. And, well, it was all physical.
So that gets us to the really big question, right? How did we get from slowly, manually flipping through cards to these massive systems that can find one tiny piece of info for millions of people all at the exact same time? I mean, the scale is just staggering when you think about it.
Well, the answer, as you can probably guess, wasn't just to, shrink the cards. Nope. We had to completely reinvent the entire library. We needed a whole new system, a digital one, built from the ground up for insane speed and a scale we couldn't even imagine back then. So, welcome to the modern card catalog. So, this new digital library, it's called a relational database. So, forget about dusty old rooms and physical cards. I want you to picture this huge, clean warehouse, and inside, all the information is stored in these perfectly organized tables. You can think of each table as its own special shelf, holding just one type of thing. But, and this is the really crucial part, all of these shelves can be linked together. Okay, so we've got this amazing digital library. It's huge, it's organized. But a library is pretty useless if you can't actually find anything, right? How do you add new stuff? Or fix a mistake in an old entry? Well, for that, you need someone who speaks the library's special language. You need a librarian. And that librarian is SQL. It stands for Structured Query Language. It's the only language that the software running our library, that's the Relational Database Management System, or RDBMS for short, can understand. So anytime you want to do anything with the data, find it, add to it, change it, you have to ask. And you ask by writing a little command called a query in SQL. But hang on. Before our librarian can even start managing all the books, they've got an even more important job to do first. They have to actually build the library, design and construct the shelves that are going to hold all that information. And this really breaks down into two main jobs for our librarian. The first one, they're an architect. They use something called Data Definition Language, or DDL. This is all about building, creating the shelves, or tables, and defining the whole structure. Then, once that's all set up, the librarian switches hats. They start using Data Manipulation Language, DML, and that's the day-to-day stuff, adding, finding, and managing all the information that lives on those shelves. And like any good architect, you don't just start hammering nails, right? First, you make a blueprint. In the world of databases, that blueprint is called an entity relationship diagram. It's basically a map. It shows you every single shelf or table, what kind of info is supposed to go on it, and most importantly, how all those different shelves are connected to each other. So once that blueprint is all finished, the actual building can start. One of the most basic DDL commands is create table. And it's exactly what it sounds like. It's you giving the librarian an instruction to build a brand new shelf. You tell it what to call the shelf and exactly what kind of columns it needs to hold your information. All right, the library is built, the shelves are all in place. Now we get to the fun part, the librarian's day job, managing the actual information that's sitting on those shelves. When you boil it all down, there are really only four main things you ever need to do with data. And luckily, there's a super handy acronym to remember it, CRUD. It just stands for Create, Read, Update, and Delete. Seriously, these four things cover pretty much everything you'd ever want to do. So, this is how those CRUD operations actually look as SQL commands. And you can see, right? You don't need to be a coding genius to get the basic idea. Insert into, well, that's pretty clearly about adding new data. Select is basically saying, hey, go find this for me. Each command is just a simple, direct instruction for our librarian. So let's just run through that one more time with our library metaphor. Insert, that's putting a new book on the shelf. Select, that's asking the librarian to find a specific book for you. Update, that's like fixing a typo or adding a new chapter to a book that's already there. And delete, well, that's taking a book off the shelf for good. That's really it. That's the heart of managing data. Okay, so we can build the library and we can manage all the books.
But what's to stop the whole thing from just turning into total chaos? I mean, what makes sure every book has a unique spot and that all the references actually make sense? We need rules.
And in the world of SQL, these super important rules are called constraints. They're basically limitations you put on your data to make sure it's high quality and reliable. Because without them, oh man, you could have two books with the exact same ID or a card pointing to a book that's not even there. It would be a total mess.
All right, the absolute most important rule is the primary key. So what is it? A primary key is just a special column that gives every single row, so every single book on our shelf, a completely unique ID. Just think of it like a book's official library number. No two books can ever have the same one. This is the thing that guarantees you can always find the one specific record you're looking for.
Just take a look at this example here, from a school table. See that school ID column? That's the primary key. It makes absolutely sure that every single school in this database gets its own unique number. So sure, we could have two schools with the same name in different cities, but they will never have the same school ID. No mix-ups. Ever.
Okay, so if the primary key gives every record its own unique ID, the foreign key is what links all the different tables together. It's basically a column in one table that points directly to the primary key in another table. It's like the little note on a card that says, hey, this class record, it belongs to that specific school record way over there.
And here we can see exactly how that works. That school ID you see in the class table, that's a foreign key. It creates this unbreakable link back to the school table. This rule makes it physically impossible to create a class for a school that doesn't already exist. And that's how the database keeps everything logical and totally reliable.
So why does any of this matter? What's the big takeaway here? It's that this whole system, these tables, keys, and commands, it's not just some abstract theory. It is the engine that runs our digital world. From the absolute giants like YouTube and Netflix, down to the smallest little shop online, this is how they manage their information. SQL is what lets us do more than just store data. It lets us ask it questions, find hidden patterns, and actually make sense of a world that is just overflowing with information.
So there you have it. We've toured the digital library, and we've met the librarian who speaks its language. With these tools, we now have the power to ask incredibly specific questions of almost unimaginable amounts of data. The real question isn't how we find the answers anymore. It's, what amazing questions will you ask?